Hello and welcome to my game dev stream. Today marks the start of the second sprint in the ChronoPlatformer project. If we go and take a look at our Jira dashboard, you can see we've got a new sprint burn down chart here, and we can go and see what our project looks like. Right, so I went and wrapped some things up last night off stream, but the platform epic was not complete, so that's going to roll over to the second sprint. And I did manage to finish the crouch animations. I can demonstrate that today, but it was a matter of, well, let me think where I was at when I stopped streaming. I'm really struggling to think of that. Anyways, it all looks pretty clean now. I tuned up the animation so that way it transitions from one to the next one very cleanly. I added in a new state for the crouching jump state, and I added the triggers and got all those guys set up correctly. So it does work well. I had to fix the foot colliders so that way the foot colliders were even with one another, because let's see, what was it? The left foot collider was lower than the right foot collider, and that was causing some issues, so I had to solve that. Yeah, that's the gist of it. I also went and broke down the next three features, world design, health, and setup unit tests, into their respective stories, and there are quite a lot. There were more than there were in the previous sprint. So we'll see how this goes. I'm gonna start by prioritizing setting up the unit tests. I don't want to get too much further, right? Much more code without having this system in place. See, I had a pretty bad expectation for how much effort it was going to take to do the character movement, because really that's the heart of a platformer, is the movement and the controls and making that feel nice and everything. And well, I definitely undersized that, and I didn't break it down into small enough stories. Either that, or I did too much within the first sprint. I tried to get it too, it's not obviously not perfect, but I tried to make it too nice too soon, and I might have been able to wait. Anyways, I'm pretty happy with the progress I've made so far on that, and I'm okay that the platform stuff can kind of wait until later, because I got the moving platforms and those look really cool. So now we're going to work on this epic setup unit test, and specifically the first bit of this is research testing frameworks in Unity. So I was going and looking at this on my own a bit. So I already have the UTF Unity test framework set up in my project. It came installed through the package manager, and that's already there. And I went and read a bit about how it works. There's edit mode tests and play mode tests, and there's certain restrictions for what kinds of things you can do in each. And now I'm starting with this getting started bit here. So we're going to work through some of these workflows: how to create a new assembly, how to create a test, how to run a test, how to create a play mode test, and how to run a play mode test in player. And we'll try to get through that. That'll be some good research. And then after that, we want to, my thought was to have a static unit test system where we're able to just run these unit tests. This is probably the editor tests, is my thought. The editor tests are more static. They can run without playing a scene, and these will test all the individual units in the program, like individual functions, small pieces of functionality. And then the dynamic / scene-based test system in place is probably the play mode test. So I don't know if I have much work to do here, but we'll see how much I have to set up when going through this. So we're getting started with the Unity test framework. To access the UTF in the Unity editor, we're going to go to Unity, and I've already got it open here. I'm going to close it again to show how to open it. So you go to Window, General, Test Runner, and you click that. And it opens this window. Hi, I'm W2 Melvin's dad. Thanks for joining. We're going to go ahead and drag this test runner over here adjacent to the hierarchy. That way it can sit next to here, and you can see so far right now we're in edit mode, but there's a tab for play mode, and then there's a button to run all the tests, to clear the results, and we don't have any in here yet, and that's what these little notes are about. Let's see. So that's opening that window. Nothing difficult there. So the first workflow we want to test out is how to create a new test assembly. I'm going to go ahead and read through this now. Unity test framework looks for a test inside any assembly that references NUnit, which is the backing unit test system that Unity uses. We refer to such assemblies as test assemblies. The test runner UI can help you set up test assemblies. Play mode and edit mode tests need to be in separate assemblies. And, sorry, I had to check something. In the test runner window, you'll see an edit mode tab enabled by default, as well as a create edit mode test assembly folder button. Click the button to create a test folder with the respective .asmdef, short for assembly definition, file by default. Change the name of the new assembly definition if necessary, and press enter to accept it. So my thought on this is that you should have your tests next to, like, sorted like we have our characters and environment is and stuff like that. It'd probably be good to do that. Anyways, let's just start off. Create edit mode test assembly folder. The note here says no test to show. Edit mode test can be in editor only assemblies, either in the editor special folder or editor only assembly definitions that references the NUnit.framework.dll assembly reference, or any of the assembly definition references, Unity engine.testrunner or Unity editor.testrunner. Let's just accept this, and Oh, it made it in the... So it made this in the environment folder. We can go and make one in here in the characters folder. We'll rename this file to be character test. Let's open this up in Visual Studio. We'll change that to character test. Hopefully that will be good now. Cool. Let's go rename the one in here as well. We'll do this in environment test. Save that. And that should fix up the name here to environment test, and then we can rename the file itself to be environment test. Cool, we have those two now. So in the inspector window, it should have references to nunit.framework.dll, unityengine.testrunner, and unityeditor.testrunner assemblies, as well as editor pre-selected as a target platform. So let's go and confirm that. Okay, we have nunit.framework.dll. We have these two other ones, and was there a default? Platforms checked editor. That's the checkbox here. Okay. So now we'll move on to the next workflow. How to create a test. To create a test, do the following. Create your test assembly folder and select it in the project window. Click the button Create Test Script in Current Folder option in the Test Runner window. It creates a new testscript.cs file in the tests folder. Change the name of the script if necessary and press Enter to accept it. Now you'll see 2 sample tests. Will I? Let's see. So character test. We'll do create test script in current folder. Click that. We'll call this jump processor test. Okay. All right, now we can see here the jump processor test in our list. Way to zoom in on that. Well, I'm not sure. Anyways, that's what's up here. And then it shows our 2 tests within that test file. So there's one called jump processor test simple passes, a jump processor test with enumerator passes. It says now you can open the test in your favorite script editor. You can also create test scripts by navigating to Assets, Create Testing, C# Test Script, unless adding a test script would result in a compilation error. Note, Unity does not include test assemblies when using the normal build pipeline, but does include them when using run on platform in the test runner window. Let's open that test. So we have 2 different kinds of tests. We have the test, which behaves like an ordinary method. And then we have the Unity test label here. And it behaves like a coroutine in play mode. In edit mode, you can use yield return null to skip a frame. And then we can use the assert class to test conditions. So probably something like assert dot r equal there's lots of options here. Equals whoa. So we can assert that something is false, and we can say 1 exactly equals 0, like that. And we can have a message. If that's not the case, might be getting ahead of things a bit here, but it's fine. Let's go back to here. So create additional tests. To create another set of tests in the project window, select Assets, create a new test assembly folder. In the project window, select the new folder, create a new test script in the folder, Assets, create testing C# script. The assembly definition is assigned the same name as your new asset. To rename it, change the name in the inspector window. Assembly definition names must be unique. Note, changing the file name of the assembly definition file does not affect the value of the name property in the file. Use the inspector window to make sure the name is properly changed. That's interesting because I had the opposite experience, but whatever. By default, any platform is pre-selected as the target platform for the new assembly, which means the test script appears as a play mode test in the test runner window. To change it to an edit mode test, in the inspector window, select editor only under platforms. If you have a lot of tests, you can filter in 3 ways. Type in the search box in the top left. Click a test class or fixture, such as new test script in the image above. Click one of the test result icon buttons in the top right. And when we click run all, it runs them both and they pass. Wow, we did it. So that's how to create tests. Now let's read about how to run a test. To run a test, you need to double-click on the test or test fixture name in the test runner window. You can also use one of the buttons on the top bar, Run All or Run Selected. As a result, you'll see the test status icon changed and a counter in the top right corner updated. You may also use a context menu option Run, right-click on any item in the test tree to have it with all of its children, if any, run. Run tests within Writer. It's possible to use, this has to do with JetBrains, which I don't use, so. Okay, I already figured out how to run a test. Next workflow, how to create a play mode test. Okay, not a super long little article here. To create a play mode test, you can follow a similar process as when you want to create an edit mode test. Start with switching to the play mode tab in the test runner window. you don't see the Create Play Mode Test Assembly folder button enabled, make sure that the project window you navigate out of a folder with another .asm.def. When you have your Play Mode Test Assembly folder ready, then create your Play Mode Test. Okay. Let's go click Play Mode. So I'm in the characters folder, and I can go and now click Create Play Mode Test Assembly folder. This would be, we'll call this Play Mode Test. And I'll go and I'll rename the other one to be Editor Test. So this is basically the same, except for that it has this any platform box checked. Right, that's basically what makes it a play mode test. And then I can click Create New Test Script in current folder. And we'll call this we'll also call this one Jump Processor Test. We'll see if that has an issue with that. They're in different folders. Okay. References and builds. Unity Test Framework adds a reference to test assemblies in the assembly definition file, but does not include any other references, example, to other scripting assemblies within the Unity project. To test other assemblies, you need to add them to the assembly definition yourself. For how to add assembly references, see assembly definition. We recommend putting tests into separate assemblies and using assembly definitions files. This way you'll have more control over which assemblies need to reference test-related DLLs. Play mode build with test assemblies. Note, entering play mode test for all assemblies includes additional assemblies in your project build, which can increase the project size as well as the build time. The supported workflow is to exclude test assemblies from player builds. You can choose to enable play mode tests for all assemblies to run your tests inside the editor, but this should be disabled again before building the player to prevent build failures. To enable play mode test for all assemblies, you need to set the flag play mode test runner enabled to 1 inside project settings file. Before building the player, you must disable it again, either by setting the flag back to 0 or clicking on disable play mode test for all assemblies in the drop-down menu, accessed by right-clicking on the test runner window tab. So where is that project settings / project setting.asset file? Play mode test runner enabled. Set that to 1. I don't know. That's being weird. How to run a play mode test as standalone. Let's check this one out. If you run a play mode test the same way as an editor test, it runs inside the Unity editor. You can also run play mode tests on specific platforms. Click Run All in the player to build and run your test on the currently active target platform. Note, your current platform displays in brackets on the button. For example, in the image above, the button reads Run All in Player, Standalone Windows, because the current platform is Windows. The target platform is always the current platform selected in build settings. Test results displays in the build once the test completes. Okay. Guess let's try that. So I'm in play mode and I'll click Run All Tests, Standalone, Windows 64. All tests succeeded. Click Close. Cool. That's that. So I'd say we're nearly done with some research here. I want to see what this resources page is. Testing, test-driven development with the Unity test runner. That one's interesting. Or sounds interesting. Test-driven development is the practice of writing automated tests for a piece of code before writing the code itself. In this blog post, I'm going to explain how my colleagues and I use TDD for making games with code snippets, as well as what went well and what didn't. TDD is not a fix-all, but we definitely learned a lot and became better developers as a result. There we go. The usual workflow for TDD is as follows. First, you determine what the code will do. Let's say that the code sets the value of code has run from false to true. It's simple. Next, you would write a test that checks that the code has done its job. In this case, the test would check that code has run equals true. Run the test. The test should fail because the code hasn't been written yet. If the test doesn't fail, there's something wrong with the test, or with your understanding of the code. Write the code, run the test. The test should now pass. Following this workflow speeds up the process of refactoring code and making changes because you can see straight away what is broken and why. You may wonder why we write the test before writing the code itself. This is because writing tests after writing the code can often lead to developers writing tests to make them pass. Right. You're just testing the code that you wrote. You're not testing the feature. Alright, that was my timer for doing a mini game. So let's do a bit of trivia. I'm gonna read off a trivia question related to video games, and the first person to answer correctly gets 500 points. If you answer incorrectly, you do not get any points. Okay. So, the category is video game history. Are you ready to type your question, answer to my question into the chat? The question is, what is the best-selling video game of all time? What is the best-selling video game of all time? If you get the question wrong, you score no points. The first person to answer gets 500 points. And no looking it up. That's cheating. GTA. That's a good answer, but not the right one, unfortunately. The correct answer was Minecraft. I think that there might be some level of arguability to that question on the basis of what your metric is for best-selling. The website I just looked this up on just said that was the answer. I'm assuming this is by number of sales. Rather than dollars. So Grand Theft Auto 5 is the number 2 best-selling game. Unfortunately, let's see. Yeah, these are sales in terms of copies, right? These are units, not dollars. So it might actually be true that Grand Theft Auto 5 is the highest grossing video game of all time because it sells for $60 versus Minecraft's 238 times $25. So, in fact, Grand Theft Auto 5 is the highest grossing video game of all time. But not the best selling. Some pretty interesting games on here. Nintendogs. Duck Hunt. That's an old one. 1984. Most recent one was Animal Crossing New Horizons to hit the top 50. You would rather have the dollars than the numbers? It's an interesting thought. But, well, here's the initial release date of Minecraft 2011 versus GTA 5 in 2013. Now, this isn't even quite true because Minecraft was being made far before 2011. But, I'm interested in daily active users, right? As of November 2020, Minecraft has 638 million daily active users. No, that can't be right. That's total. That can't be right. Yeah, so a lot less people have played GTA 5 than have played Minecraft, but I'm still interested in daily active users. I'm sure Minecraft is higher than GTA 5. Minecraft live player count? It says 3 million players online. GTA 5 only reached 136,000 concurrent players on Steam in November of last year. So, personally, I'd rather have I'd rather have a higher DAU count than I would gross sales. But that's because I'm not Rockstar Development and yeah, age restriction, that's definitely part of it, but as we saw, even if we scale compared to the sales, Minecraft still has more daily active users per sale. And there's other confounding factors, like, for example, the fact that most people are over GTA 5 because it is a more mature game and they're not going to be as dedicated of a fan base as people playing Minecraft. You know, like if a kid only has one game and it's Minecraft, they're going to play it all the time, but an adult has a lot more options. Anyways. We'll do another mini game in another 30 minutes on the clock. Okay. Let's go back to reading about test-driven development in Unity. It's true that it's commonly used in software development but rare in game development, and that's because it's because it's hard to do. We'll see why. Last month, 5 people from different teams in Unity's release engineer group got together to look into making games using TDD. I had heard before that some developers think they can't have automated games with their game code. Probably automated tests is what that's supposed to be. And they certainly couldn't use TDD, so I wanted to see for myself. We decided to make a few classic games: Pong, Snake, Asteroids, and Flappy Bird. The benefit of this was that we didn't need to spend any time designing gameplay because we already had a rough idea of how everything would come together, or so we thought. All very simplistic games, by the way. Asteroids is the most complex game here. While we knew how each game would work, we still had to really drill down into the concepts so we could know how to structure our test. With the example of Pong, I knew that a paddle should move, but what even is a paddle? Every idea had to be broken down. We broke a paddle in Pong down to the following attributes. A rectangle with a scale of 1/2 by 2 by 0 can move in the y plane, cannot move in the z plane, cannot move left or right, cannot move outside the bounds of the screen, has collision, has a kinematic rigid body. Okay. Doing this gave us a good starting point for writing tests. For example, you can see how complex it is just for a single paddle and Pong to come up with these attributes. Doing this gave us a good starting point for writing tests. For example, test: at least one paddle is successfully created. We do game object paddles equals create paddles. Assert that the paddles object exists. Assert dot is not null paddles. That should pass. We want to test that 2 paddles are successfully created. So we do the same thing but count that the number of paddles equals 2. From these tests, you can see that I need to write a method called create paddles that creates an array of 2 game objects. The Unity test runner includes functionality such as a Unity test. A Unity test returns an I enumerator and runs in play mode as a coroutine, which allows you to test actions that may need a frame or more to complete. In this example, we need a Unity test to check that the paddles could not leave the bounds of the board. This is interesting. They set the timescale so the test executes quickly. So it's a public function that returns an I enumerator, and it's called paddle1 stay in upper camera bounds. Increase the timescale to 20. Setup is a member of the class test setup where I store the code for setting up the test scene so that I don't have a lot of copy pasted code. So we can call create paddles for test. Let me say, get the time. Let me say while time is less than 5. We get the first paddle, we get the paddle component, we render it. We get the paddle, we move up Y, paddle 1. We increment time. And then we do this yield new return wait for fixed update. So we it'll come back to here later. After the test, it resets the time scale. Oops. It says edge of the paddle should not leave edge of the screen. So they do camera.main.orthographic size minus paddle.transform.localscale.y divided by 2. Unit test should test the smallest piece of functionality possible, so I tested each paddle for both the top and bottom of the board. If I was to use delta time here, the test would be unstable because it can vary. I set up time.capture frame rate or fixed delta time to make this predictable. If I didn't set timescale to start, test would take over 5 seconds to complete, which is unacceptable for one test. I mean, I live in a world where tests can run for 24 hours. So, but it's true. Unit tests should not take that long. Especially if you have 100 tests, right? If you have 100 tests and they're all taking 5 seconds, it's just way too slow. In the above test, I simulate moving the paddle upwards for 5 seconds. The test checks that the paddle is restricted from moving off the board by the move up Y method. When I first wrote the test, move up Y didn't have the functionality to stop the paddle from moving off the board. This meant that the test failed. It's really important to check that your test actually fails after you write it, but before you add the actual functionality, or you could end up with false positives. Early on in the project, while I was still getting the hang of everything, I wrote a test, forgot to check that it was failing, then noticed that the tests were passing even though the functionality was broken in the game. When I went back to check my test, I realized I'd written it wrong. I'd actually forgotten to call the method I was testing. It was embarrassing, but I learned my lesson and made sure in the future to check for test failures before writing the functionality. Unity Test Runner allows you to rerun failed tests, which can help speed up iteration time if you have lots of tests in a project. Oh, look at that. Asteroid Test. They have play mode test.ddl, and then they have this asteroid test. Test 1 is asteroid prefab exists. Asteroid prefab can be instantiated. Asteroid prefab has required component transform. Asteroid prefab has required component controller collider. Asteroid prefab has component controller script. Asteroid game object is destroyed on split. Asteroid split count can be changed. Asteroid can split into 2. Asteroid can split twice. Asteroid can't split thrice. Asteroid scale is cut in half on split. Asteroid can move. Asteroid direction can be changed. Asteroid moves according to its direction vector. Asteroid is destroyed when off screen. Asteroid prefab has required component sprite renderer. Asteroid prefab has asteroid layer. Asteroid prefab has required component rigid body. Wow. The good news is a lot of these are just checking that it has a component. Oops. Okay, and then we have a game manager test. Required layers exist, camera prefab exists. It goes on for a while. This test name is really long. Game manager asteroid count gets reduced after asteroid goes off screen or is destroyed. And it keeps going. They have projectile test, spaceship test. This way of working also helped us to shape how different systems would work within the game. While we were recreating games that we were already familiar with, we weren't sure how individual systems within the design would come together. Writing the test first meant that we could plan out how we wanted things to work, and then put them into practice to see if they were actually feasible. We could iterate from there if we needed to. I also found that using TDD caused me to write better and neater code because I was putting more thought into what I was writing and why. It's very important to bear in mind that TDD is not a fix-all, but it's a nice safety net, and it allows for faster iteration in the project once all the tests are in place. Seeing all the green ticks appear in the Unity test runner window was a really satisfying feeling too. However, using TDD doesn't mean you don't need any other kind of testing. TDD is a quality-driven development approach rather than a QA strategy. And they have a repository here on GitHub that we can go look at. So this person here makes a comment. She says, "This is great, but the hardest part, in my opinion, is the implementation of create paddles for test. How do you do that? Is this repository publicly available?" In fact, yes, it is. Create paddles for test. It creates a board, and then it calls board.createPaddles and then returns paddles. And so the board manager is going to be somewhere else. It's going to be under scripts, board manager.createPaddles. And it just creates one game object called paddle1, sets its position where it wants it to be, and then adds a component called a paddle. And then does that a second time, and then makes an array of them, and then returns the array. And then we can look at the paddle script as well. What's in a paddle script? Basically, it just has a speed. Let's see, on start, we call render paddle, add collider, set tag on paddle, add rigid body. So what is render paddle? Transformed at local scale equals what it should be. Add a sprite renderer. And then we set the sprite to... Interesting. I'm learning stuff here. Asset database.load asset at path. You give it the path and the type, and it will load it. Cool. Add collider just adds a box collider to it. Set tag on paddle just sets the tag to be paddle. Add rigid body just adds a rigid body and then makes it kinematic. And then on update we call get input, and get input does the it gets the two input axes, vertical 1 and vertical 2. This can probably be more streamlined. Yes, I agree. I don't like that you have to check both of the paddle, or both of the input axes, and then like call both move upwise. That's just weird to me. But I guess if you call move up Y and your paddle name matches, or move down Y and your paddle name matches, then we make sure that we aren't going past here. Otherwise we do this business. We move up or down, and then we return our position. And there's a move X function, but it does nothing. It just returns the current position. And then we have this speed bit here, and the speed is never used. They just hard-coded the 5. Okay. Okay, there's also a page here about extending UTF. I'm not particularly worried about that. Okay. Now this is back on the page that I started at, and this is talking about test your game code. It goes through overview of the test runner API. Splitting build and run. Launching specific tests from a menu item. Running tests before the build. Meh, could be better. I don't see the point of this page. Alright, I'm not doing your review. Okay, that's interesting stuff. I'm going to say my research testing frameworks in Unity is done. And now for the next bit here, these two sort of go hand in hand. Static unit test system in place, dynamic or scene-based test system in place. That's basically what we already have. So in characters we have editor tests and we have play mode tests. And we have this is our assembly definition asset. And then one of our actual tests. Okay. So the file should be named like this. In the characters folder, we have everywhere we want to have tests, right? Like characters, we have two folders: an editor test folder, and then a play mode test folder. And then we have our assembly thing that we're gonna call character editor test. Okay. Click apply. And that should do its thing. We're gonna have to recompile probably. Okay, now in edit mode tab we have character editor test, jump processor test. Cool. And then we have play mode tests, and we have play mode tests, but I want the name of this to be different. I want this to be character play mode test, because we're going to have one of these in every single file. Well, not every single file, but like we'll have one in characters, one in environment. I want the file name to match the name of the assembly definition. Okay, we'll change this one in environments to environment editor test. Click apply. do assets, create, testing, test assembly folder. This will be called play mode test. Okay. That creates this one in here, which we're going to rename to loading. Environment play mode test. Apply that. I shouldn't have these spaces in here because I haven't been following that style other places. Okay, and these other guys don't show up in here yet because we don't yet have an actual test in these folders. So what's in the environment? We've got a prefab here for a ground and a moving platform. Let's go to editor test and we will do assets, create, testing, C# test script. This will be called ground test. We just make that. And then now in edit mode, we have our ground test as well. And so when we run all, it runs all of them. We'll do the same thing in the play mode test folder. We'll do assets, create, testing, C# test script, ground test. All right, we'll start our next mini game here in just a minute. But if we click Run All Tests, then it will run all four of these test cases. Gotta wait for the Unity loading screen, of course. Interesting. That closed on its own. But they all passed, so whatever. I don't think it's supposed to close on its own like that. Hi, Dalton Jones. Thanks for joining. We're gonna do a viewer mini game here. So I'm glad you joined. Anyone you know who wants to join in the mini game should jump on the stream right now. It's gonna be a trivia mini game. Can I get some thumbs up or something in the chat? Everyone say if you're ready. You know, I'll just assume you guys are ready. I'm not seeing anything in the chat right now, but I'll assume you guys are ready. Oh, we got thumbs up. I don't know if anyone's actually watching on YouTube, but if you are, trivia time. Okay, so here's how this is gonna work. I'm gonna read off the question for trivia, and the person who answers the quickest gets 500 points. Okay, and that means you might move up on the scoreboard here of the best viewers. If you answer incorrectly, you get no points, and if you are not the first person to answer, you get no points. So you have to be first and be correct. Well, the first person to be correct. I think you guys get the idea. So, here is the trivia question. Blizzard Entertainment is most well known for what video game franchise? Who knows the answer? No using Google. Well, this might be a bit of a subjective answer, but the correct answer is World of Warcraft. It's not GTA. It's not GTA MW2 Melvin's dad. The correct answer was World of Warcraft. This might be another contentious answer here, so let's go take a look at World of Warcraft sales. Let's see. Overwatch sales. Well, let's just go back to the best selling game of all time. We were looking at Wikipedia earlier. So, is Overwatch on here? Overwatch is not on here. Is World of Warcraft on here? It's also not on here. Whoa. I got all those letters wrong. I deem the correct answer as World of Warcraft. No, it's not Mario or Sonic or Pokemon. Blizzard Entertainment made none of those games. I'm sorry, Drew Lives Pinky. You get no points for that. But let's see here. Dalton Jones, 1297, minigame 1. And you guys. Also, thanks for joining. You get 100 points for your first comment of the day. So let's resort the top viewers. Let's see who shows up when it refreshes here. Oh, look at that. Look who is in third place now. Dalton Jones, great job. So, currently, since I have some viewers right now, I'll explain what's going on. Nice Doritos. I'll explain what's going on. I'm looking at setting up unit tests for my game project, so that way I can test the code that I write, or better yet, I can write the tests first and then write code that passes those tests, and that's a good way to run things. So I did some research on testing frameworks in Unity, and then I've got a testing system in place to do static tests, and is also static or scene-based tests that are like the game is playing. So those are all set up now, and I can start to actually work on these unit tests. But since I have some viewers right now, and because I promised to show something kind of interesting, I have an update to show from the stream from last night. I was working on having a better animation controller for the player jump. The drawings aren't any better, it's still just a stick figure guy, but having an animation controller means that you can move from one state in the animation to another, like you're standing still versus walking versus crouching and jumping and falling. We'll have all those different states. And then I've also got a little, I can make a little scene that has like a moving platform as well. So I'm dropping in some prefabs. I've got the ground bits, and then I've got the player here, and I've got a moving platform in here, so that'll be kind of interesting as well. So when we run this, we can see what's going on. Zoomed in kind of far right now. So there's this moving platform which goes and does its thing, and then the player can move around. And when he's walking, there's no separate animation for walking versus idle right now. But what I do have is that when I press, oops, I missed the space bar and just barely grazed it. When I press down the space bar, no. You're saying whoa, but it's not working like I expected it to. can jump on top of the platform too, and I move with it, which is kind of neat. Why aren't these triggers being added anymore? I think I messed something up slightly. I think the fix is that I don't have the player animation trigger script on my character anymore. Which should be a simple fix. I just need to drag it into here. Okay, so now you can see when I press down the spacebar, he goes into this kind of crouched position, which you can see here. And then when I release, oh, clearly not everything is perfect yet. I was like clicking and messing and zooming and stuff while the game was going. Probably didn't like some of that. So you don't currently move with the platform. That's a feature I have scheduled for later. But you can see when you fall off of it, you go into the falling animation. And when I press down the spacebar, I go to the crouch, and then as long as I'm in the air, I'm in the falling animation, which is like that. And right now the animations are also very simple. It's just a single picture, but I could have a sprite sheet and it could like alternate between like hands like this versus like this, and so it'd be like waving back and forth like he was falling, and that'd be really easy. Okay. Just wanted to demo those things there to show that was what I was wrapping up last night, was the player animation trigger and the player animation controller and that sort of business. Thank you. Thank you for the nice progress comment. Pretty happy with where I've gotten so far on that stuff. Okay. I think I probably want to go for about another 20 minutes, see if I can get to 2 hours for this stream. The next thing to work on is to continue work on setting up the unit test. So I have 4 more stories here in the unit test deal, and my intuition would say that I should take shortest job first. So there's 2 that I've sized at 5, and then 2 that I've sized at 3, and there's 1 here for unit tests for ground platforms and 1 for unit tests for horizontal movement. I have a feeling that the ground platforms are going to be easier than the horizontal movement. Yep. So now's time to go look at the test runner. This will probably be a play mode test or something. Let's first look at what the ground prefab has on it. It doesn't even have its own script. So there's no code to test statically. This is entirely just like, let's instantiate a ground into the world and test that its behavior is mostly correct. We already have this file here called ground test, and that's what we're gonna go based off of. These are example tests that are already in here. I'm going to leave them until I have a good idea of what's going to be in my test. So, you know, what is the accurate behavior of a ground platform or whatever, right? It should it should have a collider. It should have a sprite renderer, so it can, you know, be drawn. It shouldn't move. Doesn't have a lot of interesting behavior. Let's look at again at some of the things that they were using in test-driven development to talk about the paddle in a Pong game. They expect it to be a certain size. They allow it to move in certain planes but not other ones. Has collision, has a rigid body. Then here we were looking at this picture where they've got stuff like for the Asteroid game. And they say test 1, prefab exists. The prefab can be instantiated. Has a transform, a collider, a controller script. Some of these seem kind of simple, but I guess why not? Say prefab exists. Prefab can be instantiated. Can you use your points on here to pay your rent? No, but if we get to 50 followers, you can, or if you subscribe to me, I can use those points to pay my rent. So, yeah, let's get to 50 followers, guys. Actually, if we get to 50 followers, we'll have all sorts of, we can have some cool new features on the channel that like reward you for watching, you know, a little bit better than my handmade system here on the screen. Like I have to go and update an Excel document and save it every time I want to change that, and it's fine, but it's not the best. So Twitch has a lot of nice features that you can do by default if you have 50 followers, and there's a couple of requirements. The first thing is that you have to have 50 followers. The next thing is that you have to stream for 8 days in the past month. If I get to 100 followers, I will not pay your rent as well, because just having followers doesn't make me money. You have to subscribe to me. A follower is different from a subscriber. You see, a follower on Twitch just means that you get notified whenever I go live, but a Twitch subscriber means that you're, like, I don't know, giving me part of your Amazon Prime membership or something. I don't know. It's weird. Twitch is owned by Amazon, if you didn't know. You can also do these things called bits. You can give someone bits, and it's like pennies or something like that. Each bit is a penny, and you can... it's just another way for Twitch to make money. I also need to have an average of... I need to have an average of 3 followers over the last month, or 3 viewers per stream, basically. So it's good right now that we've got 4 viewers. We're boosting up the average. I'm not gonna pay his rent. Boo. Boo to paying his rent. Okay, these will be the tests I tried to set up for the ground, I guess. So the formula, or, you know, recipe for typing up one of these unit tests is like this. You got an I in numerator, and then the name of your function. So can, or let's say does, prefab exist? Maybe this one doesn't actually need to be a Unity test. It must be a regular test. So they have tests set up. They do create paddles for test, create camera for test, create ball for test. And then they have destroy all, which just destroys everything. I kind of like the idea of having this, particularly this one. Seems like a really good idea. So I'm going to do that. I'm going to go into here. And this won't belong in any one of the test folders in particular, but just in system scripts, and then I'll create a folder here called tests. And then in here, I'll make a C# script, and this will just be called test tools. So this will be a public static void function, and it will be destroy all objects. Do for each game object O in object dot find objects of type game object O dot destroy. Or is it just destroy? No. Like that. Destroy immediate. It's dramatic. Destroys the object immediately. You are strongly recommended to use destroy instead. Well, I don't want to delete any of my assets, so I'm just going to use regular old destroy. Instead of destroy immediate, because apparently you can accidentally just delete your art and other assets like sounds, and I don't know, that's weird, but it sounds dangerous. It's not in the same folder, so I don't think it can find it. How to Unity test framework include script. Okay, so in order to do what I want to do, I have to make an assembly definition here. Do create testing. No, just create assembly definition. Test tools assembly definition. And then we can have our other ones reference this. and editor test. I'll add in test tools, apply, and then play mode test. We'll add it again here. Tools. Okay. Let's clear that. Now, oh, I didn't apply on the one that I needed to. Haha. Okay, so now I can call test tools from inside of my test. And as a pre-test thing, we're gonna always destroy all the objects before every test. And also as a post-test. Public void can prefab be created? Test public void does ground have a position? Does ground have a collider? Does ground have a sprite renderer? Oops, that's neat. That needs a test thing there. And this last one I think will be a Unity test because it needs to be done over time. So public I enumerator does ground move when collided. So in paddle test, they do paddles have sprite renderer. So they get the paddles using the setup create paddles for test. And then they go through all the paddles. And they check that it's not null. Otherwise, they print out this business. Okay. I don't know. Let's see. They use asset database.load asset at path. Let's try that, I guess. What is asset database then? So they do load asset at path. Returns an object, you give it the asset path, you give it the type. It says returns the first asset object of type at given path asset path. So maybe we should do load all assets at path and check that it's only one. Oh, that will return different types of things. This one you have to give it a type. So let's do that. Load asset at path. Assets slash environment slash prefabs ground.prefab. Unity asset database load prefab. Okay, so that one should work as long as we have the deal. Cool. let's click run all. Okay, well, I think it stopped running. Ooh, that's what I should be doing, not type of game object. I should be doing type of ground. But I can't access that. No, I don't think so. Okay. So this will try to instantiate a game object, and if it's not null, then we pass that test. And I'll just run this, and I'll run this one in particular. Can prefab be created? And it's still got a green check mark, so that means it passed fine. All right. So let's check in the work we've got for today to plastic. This would be something like set up Unity test framework folders and assembly definitions. Made some unit test cases for the ground prefab. So let's talk accomplishments. Did a couple fun trivia mini games for the viewers. Learned a lot about Unity test framework. Learned about test-driven development. In Unity. Learned destroy immediate is dangerous. Learned a bit about assembly definitions. Set up editor and play mode test folders for characters and environment. Learned how to run Unity tests. Started unit tests for ground prefab. Next time, finish testing ground object. Work on moving, let's just say work on other objects. All right, so thank you to those viewers who joined. I hope you had a bit more of an entertaining time this go. Please join again next time, and as always, have a nice night.